Hello everyone, this video is all about the Magnus effect. Let us explain it to you. The Magnus effect is a phenomenon in fluid dynamics that describes the curving or bending of the trajectory of a spinning object moving through a fluid. This effect is most commonly observed in sports like soccer, tennis, and baseball, where a spinning ball exhibits a curved path. The Magnus effect is caused by the difference in air pressure on opposite sides of a rotating object due to its spin. When an object, such as a cylinder, spins as it moves through a fluid, it creates a difference in airflow on its two sides. This results in a pressure difference. One side experiences higher airspeed and lower pressure, while the other side experiences lower airspeed and higher pressure. The higher pressure side of the object deflects the object's path toward the lower pressure side, causing it to curve. Now let us perform an experiment. We set up a homemade boat, and on it, we placed a small engine that carried a plastic cup on top of it. The engine spans the cup, creating a rotating cylinder. We placed the boat in the water and blew air on it while the cylinder was rotating, and we were able to clearly see the Magnus effect happening. In order to calculate the theoretical value of the force that was created by the Magnus effect, we approximated and analyzed the flow around a cylinder using a combination of several idealized flow patterns, including a doublet, a steady flow, and a rotating flow. In addition, we assumed constant density, a large Reynolds number, non-rotating flow, and constant angular speed of the cylinder. With these in mind, we were able to calculate the theoretical force using the following equation. We calculated the angular velocity of the cylinder by marking it and analyzing the video shown in slow motion. In addition, we used a software called Tracker to figure out the flow rate from the fan we used in the experiment. In order to calculate the measured force, we once again used Tracker to figure out the acceleration of the boat, and then we used Newton's second law to calculate the force. The result was that the force on the boat was the following value. We made two major assumptions when calculating the force. Firstly, we assumed that the acceleration of the boat was steady because it was created by a force that is supposed to be steady. Secondly, we neglected the effects of friction. Both of these assumptions were likely the main cause that created the difference between the theoretical value of the force and the force we measured. Hope you enjoyed the video and thank you for watching.